All right. So what we're going to talk about today is factors. This week we're going to talk about the difference between factors and multiples. Okay? We're really going to talk about what's the difference between those two. So today and tomorrow we're going to focus on factors. On Wednesday we're going to focus on multiples. Okay? Your I can statement for today is I can find the greatest common factor of two whole numbers. That needs to be written at the top of your note page. I can find the greatest common factor of two whole numbers. Is there an S at the end of factor?
What?
Is there an S at the end of factor?
Oh.
Notice that means it's just going to be one number. On your homework several times, you choose more than one.
Plural.
It's not plural, it's one. Okay? Factor is one. We're going to talk about that why in just a minute.
I'm confused. You choose more than one, isn't it plural?
Yeah, but do you see an S on the end of factor?
No, because it's
So it's just one.
how come there is
All right.
wait.
We're going to move on. All right, so this is the top of your note page that you will see. It says a number is blank of other numbers called factors. Numbers are made of other numbers. So that's your first blank. That's something you've really got to understand and you should know by now, but sometimes that gets lost in translation when you're younger. Numbers are made of other numbers. Okay, you can multiply numbers together to get any other number. So, think about your family, right? Your family is made up of other people, right? It wouldn't be a family if there's not other people involved. Okay? Biologically, there was two people to make you. Okay? That's how it happens. You have a family, whether you live with them or not. Just like numbers, they have a family that makes them up. Just like you had to have a mommy and daddy make you, these numbers have to have a mommy and daddy that make them. Okay? So factors are made up of other numbers. So for example, 2 times 3 equals 6. 2 and 3 are factors of what number? Of 6. Are there any other two numbers that can multiply together to give you 6?
Yes. 6 times 1.
6 times 1. Okay, those are also factors. They're family members of 6.
Okay. 6 doesn't have that much family.
Nope, 6 doesn't have a big family. It's a small family.
It has a mom and dad.
It has a mom, dad, brother, and a sister.
Oh, I thought it was grandparents.
Or grandparents. You can be grandparents if you want to. When a set of numbers has the same factor, it is called a common factor. If we have something in common, that means we share that. Okay? If we have something in common, that means we share it. Looney Tunes likes Looney Tunes.
You like them.
I like Looney Tunes. We have that in common. Okay? That's what common means. The blank is the largest factor that a set of numbers has in common. The greatest, or the GCF, you want to put greatest under there, you can. The greatest common factor is the largest factor that a set of numbers has in common. The greatest. Can there be more than one greatest?
No. Yeah, no.
No. Can there be more than one OG?
Yeah.
No. Or goat. What is it called? Goat, right? Greatest of all time. Can there be more than one goat?
Yes.
No.
I'm going to go in the spawn.
All right. So, if we're in a race, and me and Reese are racing,
You don't win.
and if Reese beats me, he won, right? He got first place. Can Can more than one person have first place?
No.
If we try to find the greatest or the tallest in this class, are we going to have more than one?
Yeah.
No, we're looking for the tallest, the number one. Can you have more than number one?
No.
No. So when you have a greatest common factor, can you have more than one number?
No.
No. If I'm looking at my factors and I have 6 and 12, can 6 and 12 be my greatest common factor?
12 is.
12 because it's the greatest number. Okay? So we can only have one. Alright, so here's a Venn diagram display of finding the GCF. Now your instructions will say to use a factor tree. I don't like to use factor trees.
What is a
Okay?
factor tree?
It breaks it down and looks like a tree. I'll show it to you if you're really interested later on. We're going to make a list. Okay? When you start listing out your factors, you always start with 1 and itself. You need to write that down somewhere. Always start with 1 and itself. So for example, if we're going to find the factors of 15, we're going to start with 1 and 15. Always, always, always start with 1 and itself. So I would list 1 and 15. That's part of its family.
Oh, that's
All right. Then I'm going to, what's the next number after 1? What comes after 1?
2.
2.
But
Is 2 a factor of 15?
no, because 15's odd.
Because 15 is odd, and according to our visibility rules, it has to be even. So 2 won't work. So then we go to 3. Will 3 work? Yes. 3 times what? 3 times 5 will work.
6 won't work because it's not divisible.
All right. So before we get to 6, I want you to notice something real quick. There's only one number in between those, between 3 and 5, which is what? 4. Will 4 work? No, 4 is not going to go into 15. So that means we're done. You see how we've kind of encroached on each other? There's no other numbers to use. So the only factors, the only family members 15 has is 1, 3, 5, and 15. Okay?
Well, they're kind of wrong.
All right. Now we've got 60. I'm going to go ahead and tell you 60 has lots of family members, so you're going to want to make sure you have plenty of room for them. What do we start with?
1. 1 times 60.
1 and
60.
60.
2 and 30.
So why will 2 work?
Because it's an even number.
It's an even number. So 2 times 30.
3 times something.
All right, will 3 work?
Yes.
Well, our rule for 3 is if the sum is a multiple of 3. So if I add 6 plus 0, I get 6. So 3. We know 3 will work. 3 times what is the question? Casey. 20. Will 4 work?
Yes.
Yeah. How many times?
3 times 1.
15. 4 times 15
5 and 12.
will work. 5 and 12. Well, 6.
Yes. 6 times 10.
6 times 10. Will anything else work?
Yes.
Will 7 work?
No.
8?
No.
9?
No.
So then we run into 10 and we've tried everything else. So that means we're done. We can use this Venn diagram to see what they have in common. Somebody tell me what goes in the middle of a Venn diagram.
No, it's the same common.
What they have in common. Okay, so let's go through our list. Do they both have 1 in common?
Yes.
Yes.
No.
Do they both have 2 in common?
No.
Where 2's over in 60. Do they both have 3?
Yes.
Yes. So that's going to go in the middle. Do they both have 4?
No.
No. Do they both have 5?
Yes.
Do they both have 6?
No.
10?
No.
12?
No.
15?
Yes. No.
20?
No. No.
30?
No.
60?
No.
Now we can look and see what do they have in common. What's the greatest common factor there? What's the biggest number in the middle?
15.
15. So guess what your GCF is?
15.
Now, do I have to draw a Venn diagram each time?
No.
No, I don't have to draw a Venn diagram. I could have gone through that list just like I did and said, what do they have in common and what's the biggest number they have in common? Is 1 and 3 and 5, is that a GCF for it?
Yeah. No.
They're common, but is it the greatest?
No, it's LCL.
Mm-mm.
It's common multiple.
Nope. Factors are what you multiply together to get the number. Okay? Factors are what we multiply together to get a number. What do we always start with?
A 1.
1 and
The highest number.
not the highest number, itself. 1 and what?
Itself.
Itself. That's right.
What's the highest?
All right. We're going to move on. So we can list it, we can put it in a Venn diagram, or we can use the slide. Okay? We talked about the slide a few weeks ago. Remember with the doodle notes? It's called either the ladder method or the slide method. Okay? So we're going to practice using that. So we're going to put 20 and 16 in the slide. I do it, you do it. It's on your paper already, okay? We're going to decide what factors can we do. We always try 2, 3, 5, and 7. Will 2 work for 20 and 16?
Yeah. No. Yes.
The rule is they have to be even. Are they both even?
Yes.
So can we use 2?
Yes.
20 divided by 2 is
10.
10. Not
8.
multiply. 16 divided by 2 is 8.
And then we can do 2 again because they're still even.
We can do 2 again because they're still even.
5, 4. Wait. And
All right, just a second. Let everybody catch up. Is 5 and 4 both even?
no.
No. So we can't do 2. Will 3 work for both of them?
No. No. This
No.
the thing you have to multiply now.
All right. 5 will work for 5, but will it work for 4?
No.
What about 7?
No.
No. So here's a way you can remember. Are we done?
No. Yes.
Is there anything else we can take out
No,
they have in
no.
common? No. So what you do is you're going to draw a G for the greatest common factor around those two numbers.
And a ladder. I mean,
Right.
a roller thingy around the oblong or LC.
So 2 times 2 equals
4.
4. So our GCF
It's 4.
equals 4.
It's always got to be smaller than the
Right. Your GCF is always smaller than your 2 original numbers. So 4 is a factor of 20 and 16, and it's the greatest common factor that they have. So we've used 3 different methods to find the greatest common factor. What are the 3 methods that we've used so far?
ladder.
We used the ladder. What was the first thing we did? We made the list. So you can use the ladder, a list, or the Venn diagram, right?
I like this one.
You have to decide which you like best. The list, the Venn diagram, or the ladder. Okay? So for 24 and 40, we're going to try the slide or the ladder one more time. So we've got 24 and 40. What can we try first?
2, because they're both even.
2, because they're both even. 12 divided by 2. 24 divided by 2 is
20.
12. 40 divided by 2 is
20.
Can I stop?
No, because they're both even. Use 2 by 2
We
again.
can use 2 again because they're both what? Everybody. They're both what?
Even. 10 and
12 divided by 2 is
6. You can do 2 again.
10. Guess what? They're both
Even.
So what can we pull out?
2.
6 divided by 2 is?
3.
10 divided by 2 is?
5.
Are they both even?
No.
So I can't use 2. 3 will work for 3, but will it work for 5?
No.
5 will work for 5, but will it work for 3?
No.
Will 7 work?
No, we're done.
So guess what?
You're done.
We're done. So we're going to draw our G. This is where you mess up the most. We've got 2 times 2 times 2. Several of you are going to go 2, 4, 6.
No, it's 8. Because 2 times 2 is 4 and 4 times 2 is 8.
2 times 2 is 4. Bring down that 2. 4 times 2 is
8.
8. So our GCF is
8.
So tomorrow we're going to practice that more. Okay? You're going to get an opportunity to do some interaction and to do some practice on that. How do you feel so far about some GCF?
Just easy. This was easy.
All right. Factors. Do they make up the numbers or are they the numbers?
Make
They make up the numbers. They're the family members. Factor are the family members. Factor, family. Factor, family. Okay? All right. You can pack all of that up. It's almost time to go.
Already?
Already. It was by fast, didn't it?
I know you are.
I'm gonna leave it here.
It's a good here for you. Hot.
I'm gonna leave it here.